Today we will be talking about complex numbers. So our objective is to write these numbers in standard form and then compute operations with these numbers. What is a complex number? A complex number has two parts. It has a real part, which could be a real number, a rational number, an integer, a whole number, and a natural number, or an irrational number, and an imaginary part. And this imaginary part might have some multiplier, but it's got an I at the end of it. And we know that I is the square root of -1. We can go from there and see that I squared becomes -1. What happens when I get I cubed? That would be -1 times the square root of -1, which would be negative square root -1. And I to the fourth then becomes negative square root of -1 times square root of -1 again, which becomes a positive 1. Okay, so it's important to realize that complex numbers include all of these numbers inside of them. A complex number could be just the number 9. It does have a real part. That real part is 9, and that imaginary part just has a multiplier where that b is 0. So we would have 0i. Now, what this really means, because it's like weird to have an imaginary number, right? Is that we're looking at an axis like this. On one axis, there's the real numbers, and on another axis, there's the imaginary numbers. So this is kind of a vector that shows us a direction towards a point on the real axis and the imaginary axis. It tells us this point's position in relation to these two axes. Okay, so in standard form is this a plus bi part. A plus bi. In standard form, this could be a fraction over here. This could be a square root. Same thing with the b. It could be a square root or fraction, and the I comes at the end. So the b is a coefficient of the I. Now let's talk about performing operations with these complex numbers. So my first operation is just addition. So I'm just looking, and just like with any other variable, I is not a variable. It stands for one number and one number only, which is square root of -1. But just like with any other set, if this was 6x or 3x, I would go ahead and combine like terms. So what I'm going to do, I see 4 and 3, those are like terms, so I can add them and I'll get 7. And I can add my 6i and my -3i, and I'll get positive 3i. That is my final answer, and that's in the form a plus bi. Now our next operation is addition. Very similar to, now our next operation is subtraction. Very similar to addition. All I'm going to do is I'm going to make sure that I first distribute this negative before I combine like terms. So I could rewrite this as 6 minus 5i minus 1 plus 6i. I'm going to go ahead and combine my 6 and my -1, and I'll get positive 5, and I can combine my -5i, my positive 6i, and I'll get 1i. Next, we have multiplication. So what I'm going to do with multiplication is make sure that I am foiling, right? This is a binomial times a binomial. So what I need to make sure to do is distribute and FOIL. So I'm going to multiply 4 times this 7, and I'll get 28. I'm going to multiply the 4 times the -3i. I'll get negative 12i. I'm going to multiply my 2i times 7, and I will get plus 14i. And then I'm going to multiply 2i times -3i. So I'm going to multiply my coefficients together, 2 and -3. That will give me -6. And then I have I squared. So remember that we said I, oops, So remember that we said that I is square root of -1. So I squared would be square root -1 squared, which is just -1. So I'm going to go ahead and I'm going to think about this as being -1. And then I'm going to combine like terms again. I have 28, and then -6 times -1 is going to give me +6. And then I have -12i plus 14i. That leaves me with 2i. I'm going to go ahead and combine my 28 and my 6, and I'll get 34 plus 2i is my final answer. Okay. Now, we don't have any i's here yet, but we have two negative numbers which are under radicals. We cannot have an even root of a negative number. That's not a real number. That's an imaginary number. So I'm going to go ahead and break down. This is square root of 12 times the square root of -1. I could rewrite that as square root of 12 times I. And I'm going to put like a little barrier there to show that I is not under the square root. The square root stops at 12. And then I'm going to do the same thing with my square root of 48 times I. So now what I have is I have the square root of 12 times 48, and I have I squared. Okay, so what I can do now is I can do the whole process of breaking down 12 and 48 to see if there's any numbers that I can pull out of my square root. I'm going to do that all the way up here. 12 times 48, I can break this down into factors. This would be 3 times 4. 4 is a perfect square, so I know I can pull that out. 48 would be 3 times 16. 16 is a perfect square, so I know I can pull that out. And then 3 times 3, I know I can pull that out. So what that would leave me with, oops, nothing under the square root. I would pull out 1, 3. I would pull out 2 because that's a square root of 4. And I would pull out 4 because that's a square root of 16. And that would leave me with 3 times 2 is 6 times 4 is 24. Okay, so I'm left with 24i squared. And remember, we said that I squared is equal to -1. So now I've got 24 times -1. And my answer is -24. All right. Next, we're still doing multiplication, but I've got something squared. I need to remember, again, this is a binomial. So instead of just squaring everything in there separately, I need to write this out as two separate binomials and then go through the FOILing process. Okay, so I see that I'm going to have -1 times -1. That will leave me with +1. I'll have -1 times the square root of -3. Okay, negative, and then I'm going to break that up into square root 3 times I. Here I'm going to have the same thing again. -1 times the square root of -3, so it's negative square root 3 times I. Now I've got square root of -3 squared. Anything squared is anything that's a square root of something squared is just that original thing. So that will give me -3. I'm going to go ahead and combine like terms. 1 and -3 will get me -2. And -3 root 3i, negative root 3i, that will get me 2 times negative root 3i. Okay, so this would be my final answer. This is my A part, this -2. This is my B part, this -2 times square root of 3. And there's my I, A plus BI standard form. Okay, the last thing we're going to talk about today is complex conjugates. So complex conjugates, a conjugate is keeping the same numbers that we see. So we have, what is the complex conjugate for 4 minus 5i? I'm going to keep the numbers, but I am changing the magnitude of the imaginary part. So I'm changing from a negative to positive. If I was originally given a positive, I would give a negative. And so we can kind of recognize here we have a minus bi and a plus bi. So similar to that problem we did in class, where we were looking at a difference of squares. I know that a minus b plus times a plus b will give me a squared minus b squared, a difference of squares. So I can tell, I can generalize that this will give me a squared minus bi squared. Okay, so let's go on and multiply some complex conjugates. I'm going to do the same thing. I'm going to FOIL. We'll do this one out. So 3 times 3 is 9. 3 times negative 2i would get me negative 6i. 2i plus 3i times 3i would be positive 6i. And then I have 2i times negative 2i. That would give me negative 4 times I squared. Okay, so I'm going to go through and simplify what I can. Negative 6i and positive 6i will cancel out. That will give me 0 in the middle. Now we said that I squared is negative 1. So now this becomes 9 minus 4 times negative 1, which I can say is the same as 9 plus 4. So I'll get that my answer is a whole number, 13. Okay, so that's cool and all, but what this is really useful for is this type of situation. So we remember that we can't have a 0 in the denominator of fractions. Can't have a 0. We also can't have a square root in the denominator of fractions. That's why you learned how to rationalize the denominator. So these are no's, no's. And then we also cannot have imaginary numbers in the denominator. That's a new one. So how we get rid of imaginary numbers in the denominator is we multiply by a form of 1 that includes the complex conjugate of the denominator. So I'm going to rewrite my problem, 2 plus 3i over 4 minus 2i. Okay, so I'm going to multiply the top and the bottom by my complex conjugate, which should be 4 plus 2i. And I'm going to, because I want this to maintain the value of 1, I'm using that same value on the top and bottom. I'm not changing to 2 minus 3i up here. No, no, no. I'm keeping the complex conjugate of this on the top and bottom. Okay. Now, this does get a little tricky where you have to FOIL across the top and the bottom. However, I already know, thanks to finding out that this is the difference of squares up here, I already know that I can just square the two outer numbers to each other, only this time because they're a difference of squares. Normally I would have to FOIL it, but this time I can use that shortcut. 4 times 4 gets me 16, minus 2i plus 2i gets me minus 4i squared. Okay, I can go ahead and just simplify the denominator first. I know that what I'm going to get is 16 minus 4 times negative 1 from that I squared, so it's going to get me 16 plus 4, which will get me 20. Okay, so now I'm going to go back to the beginning and look at the top. I'm going to have 2 times 4, which is 8. I'm going to have 2 times 2i, which is 4i. I'm going to get 3i times 4, which is 12i. And I'm going to get 3i times 2i, which will get me 6i squared. Okay, let's combine like terms. I'm going to have, this is going to become negative 6 because that I squared is a negative 1. And I will combine that negative 6 with my positive 8 out here, and I will get 2 as my real number part. And then I'm going to combine 4i plus 12i and get 16i. Let's carry that over. So it is okay to have I in the numerator, just not the denominator. Now I do want to simplify this for sure. So I can break that down. Let's do that over here. I can break that down into, see that I can factor out 2 from each part. You know what? No, let's split up the fraction first. We can do that first. 2 over 20 plus 16i over 20. Okay, and now I can simplify those two fractions. So I'll get, when I simplify that, 2 over 20 is 1/10 plus 16i over 20, that would be 8i over 10. Ooh, we could keep going actually, right? 16 over 20, the biggest factor I can take out is a 4, so I'll get 4 over 5i. Okay, I just want to make sure you know, sometimes you might see people combine these. So that would be, if we're starting back from 2 plus 16 over 20, oops, you can see that we might be able to simplify to 1 plus 8i over 10. This is a way that you might see it written, that's simplified form, but that's not a plus bi, right? Because we don't say, okay, a plus bi over c. We need that a to be a complete number and this bi to be a complete separate part if we want standard form. So that standard form, this would be our a, this 1/10, plus 4/5 would be our b, and our I is here at the end. This is acceptable in your work and when you see simplified form, but when we talk about standard form, you need to split the real and the imaginary parts. All right.